Good afternoon, everybody. Thanks for coming. This is Nick Tedeschi with Ancom Technology, and I have Brian Layton with us. We will start the presentation here, being that it's 2 o'clock. Please type your questions in the chat box, and we will get to them at the end. So here comes the presentation. We'll talk to you in a minute.
Welcome to today's webinar. If any time during the session you have any questions, please feel free to type them out and we'll discuss them at the end. In this session, we'll be discussing our fat extraction instrumentation and specifically talking about how to make the fat extraction of difficult samples much simpler. This shows a picture, of course, and I'm sure most of you are familiar with the Soxhlet. This is, of course, one of the most common fat extraction methods that there is. It's a technique that's been around for well over 100 years. It's typically a low temperature extraction, normally taking somewhere between 4 and 6 hours, although we have had a customer or two that have told us that they've actually taken 24 hours to do a full extraction. Unfortunately, the recycling of the solvents tends to be difficult. The task is pretty labor intensive, and there's definitely a greater risk of oxidizing the fat as the solvent is removed from the oil. With our automated closed extraction system, we can increase the extraction temperature, thereby decreasing the extraction time. Normally, 1 hour is sufficient for all samples. In addition, the closed system does limit the exposure to solvents. The recovery of the solvent after the extraction is automatic with over 90% recovery. In some cases, up to 97%, as shown here on the screen. In addition, when using our instruments, you will be following an official method. There are a number of benefits that using our automated systems give you. These would include, and you can see this on the sheet here, an increased laboratory volume. Because you can do an extraction in 1 hour, you can do a number of extractions in 1 day. And you can do up to 15 samples in each extraction. Again, we have the automated solvent recovery. The oxidation is eliminated. I'd just like to talk about that for just a second, if I may. The oxidation generally occurs during the time that the solvent is being removed from the oil that has been extracted from the sample. We have found that if a lab either uses too much heat during that time, or if they don't have a nitrogen blanket to remove any oxygen from the environment, if they don't have a nitrogen blanket during the removal of the solvent, oxidation can happen with the sample. And what happens with that is that you'll get a heavier fat sample than you should. So it's going to, in most cases, overemphasize or overestimate the amount of oil that is in the sample. We can also, in this case, reduce the solvent handling, and probably, well, one of the most important things that we've found with labs is the small footprint. The instrument is just a little wider than 1 foot. Than 12 inches. So it uses very little counter space. It only requires a water hookup and, of course, a power source. It makes it very, very simple to have in a lab. We have actually 2 instruments. You can see here the XT10 on the left and the XT15 on the right. And really, if you look at the 2 instruments just very quickly, you'll see that they look very, very similar. I've added some arrows to this particular screen to show the differences. The XT10 has a solvent recovery bottle. Every time the instrument does an extraction. At the end of the process, it will indeed recover the solvent, and that bottle is what collects the solvent at the end of the run. So every time you do an extraction, you take the solvent from the bottle, you pour it into the vessel, and we'll talk in a couple of slides a little bit more about the vessel and where the samples are placed. So you pour the solvent into the vessel. So you do have a little bit of exposure with the XT10. Now with the XT15, you'll notice the solvent port on the left, and that's where you initially will fill the solvent for the instrument. In the back of the cabinet, there is a holding tank which will hold that solvent, and each time you run the XT15, the solvent is added to a completely closed system. There is no exposure to solvent during the process, the extraction process with the XT15. You can see there's a solvent site level that's pointed out on the XT15, and that will tell you how much solvent is in that holding tank, so you can know if you need to add a little bit more over time. The analytical principle, I want you to imagine this as the vessel in the instrument. It is a completely closed system, as I mentioned before. What happens is when the solvent is introduced to the vessel, the heater at the bottom of the vessel will heat the solvent to the appropriate temperature. Normally, we suggest 90 degrees C for the extraction, which is generally more than double the boiling point of the solvent. So we've heated the solvent vapors now will rise actually above to the top where you can see the condenser, and then they will create droplets on the condenser, which indeed fall into what we call the cup, the sample cup, for lack of a better term. And we have the filter bags in the cup. While those droplets are falling into the cup is then filling with solvent. When the cup finally does completely fill, it will all now the solvent will siphon back down to the bottom of the vessel. So as you can see here, it really is a Soxhlet in a can, if you will, a completely closed system, high temperature, so we have, and high pressure, so we have the kinetics for a much quicker, and I guess I mentioned before, a 1-hour extraction. When testing high-fat samples, and this is one of the samples that can create problems in labs, and by this we mean an expected fat with a meat sample greater than 20% or a plant sample greater than 40% in fat content. In this case, we routinely place the filter bag containing the sample into a pre-weighed tin. You can see the picture of the tin here on the right. During the pre-extraction drying step, it's possible that some of the low melting point fat may begin to liquefy and actually seep to the outside surfaces of the bag. By placing the bag in the tin, we're able to collect any oil that may actually drip from the bag if the sample is high enough in fat, and it will indeed also isolate the bag from touching and affecting any of the other filter bags during the drying step. Once the drying is completed, we place the tins rather than in our normal desiccant pouch. We place the tins in what we call the weigh tin desiccator, and you can see two pictures here. The picture on the left shows the drawers in the weigh tin desiccator with the tins in the drawer now going into the Ziploc bag that will protect the samples and the bags from gathering any ambient moisture during the cooling process prior to being weighed before the extraction. With oil seeds, we have another issue, and of course, if you're familiar with doing oil seeds, if you extract a lot of oil seeds, you're undoubtedly familiar with the phospha method, if you will. Because the grind size tends to be somewhat coarse with oil seeds because of their high fat content, making a grind more difficult. Many people will use this phospha method, and basically what we're talking about is an extraction, and then a grinding of the sample, and then another extraction, and another grinding of the sample, so that we're able to get all of the oil from the sample. We have two basic issues there. One is the grind size tends not to be very fine, the initial grind of the samples, simply because of their fat content. And the other is the fact that oil seeds tend to resist the solvent, if you will. It's more difficult to have the solvent to get into the molecule to remove the oil from the molecule. So what we're able to do with the phospha method, rather than grinding the sample, taking the sample out of the filter bag, grinding it, putting it back in the filter bag, what we have found is that we can use a mortar and pestle. So what we do is we extract the samples. We would dry them for just a few minutes in the oven, just to kind of, if you will, make the sample a little bit more crispy. Then we would place the bags one at a time into the mortar and hit it a few times, actually about 20 times with the pestle, being careful not to twist the pestle when it's in contact with the filter bag. We then take those same filter bags and would extract them again. And generally speaking, 2 extractions, one before the mortar and pestle, one after the mortar and pestle, is usually sufficient to fully extract the oil seeds. It is possible, though, certainly, to do a 3rd mortar and pestling of the sample, or even a 4th if desired. It makes it very, very simple to do the phospha method, and of course to get the true oil content of the oil seed samples. One thing that we get asked quite often is, how do we extract liquid samples? If I put a liquid sample in the filter bag and I try to seal the bag, it will force, pushing the 2 sides of the bag together will force the liquid to the top of the bag and will make the bag unsealable. So what we have found is that by placing diatomaceous earth into the bag, we can then have the diatomaceous earth absorb the sample and make sealing the sample very simple. So basically what you would do is to place the empty filter bag into the bag holder, and I've forgotten now the part number on that, but it is a part number that we do make available, into the bag holder so that the bag remains open, and then tare the weight of the bag and the holder. At that point, add 1 to 1 1/4 grams of diatomaceous earth to the filter bag. Using a pencil eraser or some similar object, make an indentation into the diatomaceous earth into which the liquid samples can be added using a pipette. Record and tare the weight of the diatomaceous earth. Finally, pipette 1 to 1.5 to 2 grams of liquid into the indentation in the filter bag. Be careful not to use more liquid sample than can be absorbed by the diatomaceous earth. Some high-fat liquid samples may not actually be absorbed very quickly into the diatomaceous earth. So if this is the case, what we would suggest is leave the bag open for a while and give the sample time to be absorbed by the diatomaceous earth. It may take a few minutes, but it will indeed become absorbed. You can then seal the bag, dry the sample, do the extraction, do the whole process very normally, again by utilizing diatomaceous earth in the bag with the liquid samples. Wanted to show you just real quickly, I mentioned earlier that our method is an official method, and this is very simply a regression chart from the collaborative that was performed. And as you can see, the R squared correlation is excellent. And it is an AOCS approved procedure. And you can see the AM5-04 is the AOCS official number for the procedure. Finally, we get questions from time to time regarding the use of different solvents. While the vast majority of labs, undoubtedly, the vast majority of labs are utilizing petroleum ether, there are other labs that are using hexane, ethyl ether, and even chlorinated solvents for their fat extraction. We wouldn't suggest the use of the chlorinated solvents simply because chlorinated solvents can damage the XT4 filter bag. So we would not suggest chlorinated solvents, but certainly the other three, petroleum ether, hexane, and ethyl ether, are very commonly used in the instrument. Ethyl ether can be used, but an upgrade to several of the O-rings in the instrument should be made first. Because of the different boiling points of various solvents, we have actually a program that allows you to select the solvent that you're using. So even in the same day, you could use different solvents in the instrument just by selecting that particular solvent in the program of the instrument. This chart also shows that simply by using a different solvent, you can create a different, if you will, a different fat result. And while you notice here the PET ether and the hexanes really create a pretty similar average, you notice that ethyl ether normally has a little bit higher extraction of the oil that's in the sample. So be very careful about making sure that you're using the correct solvent for your usage, whichever samples you may have. Once again, we do thank you for attending today and hope this has been helpful. If you have some questions, this would be a good time for us to discuss them.
Okay, well, thank you for being here. For those who came late, I'm Nick Tedeschi with Ancom Technology. I also have Brian Layton with me, and we are ready for questions. Questions about fat extraction, questions about the presentation. If you would, feel free to type them in your chat box, and we will give you a minute here. Can this instrument be used for nuts? Right now we have a 16-hour reflux on Soxhlet. I know the answer to that, but the answer is yes. It really depends on how the samples are ground. So with nuts or other high-fat samples, you have to be a little bit careful about not over-grinding so that you leave fat in your grinder itself. But basically, yeah, there's really no reason why you can't do nuts or other things like that. Brian, you want to add anything?
Well, and the nice thing about the system, using the filter bag, you can add extra extractions by using that mortar and pestle that we talk about in the phospha method. Even though nuts aren't necessarily considered necessarily part of the phospha group, if you will, you certainly can get added fat because you had to grind more coarsely initially. So yeah, it's a great system for nuts.
Anything else? All right, we'll give you a few more minutes if you got more questions.
One question we do get from time to time with people is those who know us because of a fiber analyzer that they've been using or have seen used in a lab. Can our fiber filter bag be used in our XT extractor? And the answer really is no, because the porosity of the F57 fiber filter bag is too large to keep the sample in when you get a good flow of solvent going through the bag. So the XT4 bag is the fat bag, if you will, and it comes in a green package, while the F57 and F58 are fiber bags and come in blue packaging. So just using those color codes will help you with the instruments getting the right bag for the process.
Okay, we got another question here. With high fat meat samples, do the time and temperatures need to be changed? The answer really is no. We find that 60 minutes, 90 degrees is really good for just about every sample. In fact, you probably could shorten it if you wanted to do the research, if you will. You know, maybe run the samples for 30 minutes, dry them, weigh them, run them for another 10, dry them, weigh them. You might find that, you know, if the weights don't change, you might find that your runtime only has to be 30 or 40 minutes. But we always say 60 minutes because we have never really found a sample that took longer. So the answer would be no. 60 minutes, 90 degrees will be good for your high or low fat samples, meat or not. So hopefully that answers your question.
It's our thinking there is you're better safe than sorry. So by adding a couple minutes, making it a 60-minute extraction, you're going to safely extract all of the fat from that meat sample. Although meat is a more simple sample, if you will, to get this extraction done and completed. But again, 60 minutes will make it safe to know that for sure the whole sample has been extracted.
We'll give a few more minutes if there's any other questions. What should I use to eliminate static when weighing diatomaceous earth? Good, very good question.
Yeah, that is a very good question, especially in the colder winter months. There is some static charge to both the XT4 filter bag and also diatomaceous earth. We use an anti-static device that we purchased from a company called Rice Lake. It's called. It works extremely well. It's actually a couple of sensors that you slide the filter bag through, and then weigh it and go through the process of putting the diatomaceous earth and sample in the bag. Anything that's going to be an anti-static device like that can work for you. If you want to send us an email, we can give you that part number. Nick, why don't you give them your email, and they'll have that available for asking that question about the anti-static device.
I'm going to put my email in the chat. N, and my last name, TEDESCHE @ancom.com. So feel free if you have questions, need part numbers, you want more information on that anti-static device, I have that information for you.
Also, if you wanted to go onto our website and just ask that question under our service email on the website, you certainly can do that too.
Well, just a reminder for people, the website is ancom.com, ANKOM.com. Our number here is 315-986-8090. Feel free to call. Feel free to check our website. And I guess at this point in time, I don't see any more questions coming through. So again, feel free if you think of anything after the fact, email that to me. And in the meantime, thanks for coming. And we appreciate your time. And hopefully this was informative to you. And we will talk to you in the near future.